Hello guys, welcome back again to Guru. Okay, today I'm coming up with another topic. We are continuing from measurement. Okay, so today I've got two topics or two definitions to iron out on the measurements. Okay, so my request is one, guys. If you are watching my videos and you know that you did not subscribe to my channel, please just subscribe to my channel and then hit the like button to show your support, guys, so that I can grow as well. And then also, guys, make sure that you go to the comment section. You can ask anything that you like to know about Maths Lead. Can you also comment on which topics would you like me to do? Okay, so after this video I'm going now to be posting previous question papers. I will be treating measurements. Okay, anything that will come now after today's lesson is going to be question papers, okay, about measurements. All right, so after this topic we are going to look at maps and plans, okay, which is still under paper 2. So what we are dealing with now, we've been dealing with paper 2. Even maps and plans is still paper 2, so we will be dealing with paper 2. Okay, without any waste of time, today under measurements we start with the surface area. I don't know what is happening. Okay, okay, I must not touch this tablet. Okay, today we start with the surface area. Surface area. You know, guys, now I like definitions. Okay, so I will start by first explaining what is a surface area, so that when we calculate we know exactly what we are calculating. Okay, so when we talk about the surface area, we talk about the total exterior of an object. Okay, we can say is the total exterior of all the exposed surface, okay, of a 3D object. Okay, so meaning that, guys, on a 2D you cannot calculate the surface area, but what can you calculate on a 2D object? You can only calculate an area. Okay, meaning that a surface area can be calculated on a 3D shape. Okay, let me give an example. I'm having this pack here. I'm having this pack of biscuits here. It's coming out of nowhere, but I'm going to use it. So if you look at this pack of the biscuits here, what can you calculate there? You can calculate the surface area. So when we talk about the surface area, we talk about the area of all the sides. So if you observe this box that I'm having here, this box, it is having 6 faces, meaning that if we want to calculate the surface area, we are going to calculate areas of all the sides. Okay, so what kind of an object do we have here? We are going to deal with them. That in surface area, which type of object do we deal with? Okay, that was just an example. And then I'm also having a glass here. This glass, it is presented in a form of a 3D shape. Okay, meaning that if this object is a 3D shape, it means we can see the height of this object. You understand? But when we talk about something like this book, let me show you. if you talk about something like this, we cannot see the height, but what can we see? We can only see the length and the width. So this is not a 3D shape, it's a 2D shape, okay? So for us to calculate what we call a surface area, we are always going to talk about a 3D shape, whereby we can see the length of a rectangular prism, we can see the breadth, and we can see the height. So in a cylinder, we can only see the base and we can also see the height. So if I'm showing you with this glass is a cylinder, okay? So we can see the base and we can see the height. We can see the height of this object. All right. So let's move on again to the definitions. I like definitions in MSP so that we really understand what is a surface area. Okay. Right. Since the total surface area is the sum of all the areas, let me write this one for you so that you can also understand what we're going to talk about. The units of total surface area are, let me start with the millimeter squared, centimeter squared, meter squared, and kilometer squared. So when we calculate the total surface area, like they're saying here, that the area, remember the term area. So the units that we use in the area are going to be the same units that we use in the surface area, because in the surface area, like I said, we calculate the total area of all the surrounding, the exterior of a 3D shape. Okay, so since we're talking about the area and the area is the product of a 3D shape, it means that the units are not going to change. Okay, now let's continue. Now when we continue, we're going to look at the shapes that we can talk about, okay? And what are those shapes, and then how do we calculate this surface area in those shapes, okay? Right, I'm going to have a shape here, and then I'm going to have the formula to calculate the surface area. I don't know if I will be able to draw those shapes, because drawings to draw is a problem to me. You see, I can't even draw this line straight. Okay, my tablet is not straight. Let me also put it this way. What am I doing? Okay, anyhow, I have space. Right, my first shape is going to be a rectangular prism. Right, I'll just try to be accurate. I don't know how I've learned to throw this like this, but it always makes sense when I throw it like this. Yeah. I've got it correct today. Okay. Now, when we observe our rectangular prism, we can indeed see our 3 dimensions. Which dimensions are we talking about? We're talking about the length, we talk about the breadth here, we talk about the height here. Okay, so if you don't want to say the breadth, you can say the width. Okay, now when you observe this, the rectangular prism, it has 6 faces. That means, or you can say it has 6 sides. Okay, it has 6 sides. And when you observe it again, let me choose a different color so that I can paint something here, so that I can maybe try to be accurate. So when you observe this, you can see that it has 6 sides. And it also means that this side that I'm painting here with red, this side, okay, let me paint this one like this. And yeah, I know the size that I'm going to paint. If I paint this one with red like this, yeah, and then let me choose another color, yellow. I can do the bottom one with this one, this one, this one. I mustn't waste time, we still have volume. Okay, now I have painted 2 sides. Let me go choose another color there so that I can paint the last. Let me use green. Okay, let me do this. Green is going to be this one, the one at the back, the one at the back. I hate the red pen, I mean the black pen must be there, or I'll just go choose black again, and then I'll come. Let me just paint. I'll go get right. So I'm just going to be quick now in explaining. Okay, so now we're going to stress about how must we calculate the surface area now. Like I'm saying, when you observe this shape, the rectangular prism, we have 6 sides, or someone can say we have 6 faces. Okay, so when you look at the red one, the red one has an opposite side. It means that the area that you're going to calculate on this side is going to be the same as the opposite side area. So they are going to be the same. That is why I've only used 3 different colors, and other 3 sides I did not paint them. I've only painted 3 sides. It means that all their opposite side, they are going to have the same areas. Okay, now let's start. we're going to call this our total surface area of a rectangular prism. Okay, how do we calculate it? We're going to say 2. I'm explaining why we have 2. We're going to have two sides that are having the same area. Okay, now we observe. Let's start with the bottom one. On the bottom one, we can only see two dimensions, which is the length and the breadth. So how do we, which shape is this one? We can see that this shape on the bottom here is a rectangle. And how do we calculate the area of a rectangle? Is length times breadth. Why do we multiply by 2? I have explained. We have two sides, which is the bottom one and the top one, that have the same area, which will be calculated using the length and the breadth. If you look on top here, we're going to use the length and our breadth or the width. Plus, remember we are looking for the total, so we must add all our areas. Plus 2. Let's go to the one at the back. The one at the back. The one at the back, if you observe our side at the back, it have the height, it also have the length. On this shape, only this shape, focus on the shape that is painted green. You cannot see the breadth there. We can only see two dimensions, which is length multiplied by the height. Okay, so this side at the back is going to be the same as the one in front. Okay, plus 2. Let's talk about the one on the left. Right, the one on the left, you cannot see the length, but what can you see? We can see our breadth and our height. So it's going to be height times breadth. And then we have just written out the formula of how to calculate the surface area of a rectangular prism. Okay, so I'm just going to show an example now. Let's say, for instance, our length is given as let me check here. Okay, 4 centimeters. 4 centimeters. 4 centimeters. And then our breadth is given as 2 centimeters, and then our height is given as 9 centimeters. Okay, right. So how are we going to calculate our total surface area? So what we have to do, we have to substitute, and that is all. Okay, so when we substitute, we're going to have 2 into, how much is our length? Our length is 4 centimeters multiplied by our breadth is 2 centimeters, plus 2 into our length is 4 centimeters multiplied by our height of 2. Our height is 9 centimeters, plus 2 into our height is 9 centimeters multiplied by our breadth is 2 centimeters. Okay, so this is going to be 2 into 4 multiplied by 2, that is 8 centimeters squared, plus 2 into 4 multiplied by 9 is 36. Yeah, that is 36 centimeters squared, plus 9 multiplied by 2, that is 2 into 9 multiplied by 2, that is 18 centimeters squared. Okay, and then we're gonna have 8 multiplied by 2, that is 16 centimeters squared, plus 36 multiplied by 2, that is 72. Yeah, 72 centimeters squared. 72 centimeters squared plus 36 centimeter squared. So if you observe here, it means we are having, this is an area, this, but this area represent our two length times breadth, which is the bottom part and the top part. We have 72 centimeters, which represent the length times height, which represent the area of the side at the back and the side in front. And we have 36 centimeters squared, which represent the total area of the side, the face on the left and the face on the right combined. So now we are going to combine all of our sides. So that is going to be 16 plus 72 plus 36. That gives me 124 centimeter squared. So that is our total surface area of this rectangular prism. So if you check here, I have set 2, 2, 2. So these twos, they confirm to you that indeed you are calculating areas of 6 faces. Okay, let's quickly move to the next object. We're going to move to the next shape. We are still under surface area, and hey man, this thing of me drawing a line is a problem. It's because my tablet is not straight, man. Let me try to put it like this. Yeah, better now. Okay. Now, our next shape in the line is our cylinder. It's our cylinder. I don't know if I'm going to win with this one. I'm not sure if I'm going to win. It's our cylinder, but let me try to draw it. We're gonna have a line here and a line here, a line here. I think I'm winning. I think I'm winning. I think I'm winning. Good. I have tried my best. So this is a cylinder. Like I said, I gave you the example of this glass. Okay, so on this example now, what can we observe here? Why do we say a cylinder now is our 3D shape? It's because we can see the height. Remember when we were dealing with the 2Ds, what could we see? We can only see the circle. We can only see the circle and the the rectangle around the circle. Now, there's something that I want to emphasize here to show what is a cylinder and what is happening in a cylinder. Okay, I want people to observe. When we are talking about a cylinder, guys, here the formula might end up confusing people, but I just want to try and explain the formula thoroughly of what it means. Okay, what are we calculating? Remember now, we are going to calculate the area around, and then if you observe our area here, it is much complicated than the area of a rectangle, this one, because the one of a rectangle is so straightforward. But when you observe our cylinder now, it is circular. All right, so we can, it is not easy to calculate, but let me make it easy for you. I want people to observe here. Look, this is my paper, which is a rectangle in a shape. This is a rectangle, but the same paper, let me show you. Look, the same paper, I am wrapping it around what? Around my cylinder. Do you see that? But look at what is going to happen. I change it back, but it is possible for me to turn it into the cylinder. So I want you to observe. I am going to unfold it. So when I unfold my cylinder now, it is going to be a rectangle. But am I cutting this paper? Am I cutting the paper? I am not cutting the paper anyhow. I'm not putting any glue. I'm just folding and unfolding. So when I am unfolding my cylinder, look, what do we call this? Is a circle, isn't it? This is a circle, this one. This is a circle, isn't it? So our circle now, what do we call this distance? We call it a circumference. Like when we were doing here, this one we call it what? A length. This one we call it a height. This one we call it a breadth, okay? But when we come to a cylinder, this, we call it, the distance here, we call it what? A circumference. Look at my rectangle. Look at my rectangle. It's not changing, but I am folding. It is only changing in shape. You understand? So it means that the length of this rectangle, my length have now became what? My circumference. And then how do we calculate a circumference? A circumference now is calculated by saying pi d or 2 pi r. That is how we calculate the area of a circumference or of a cylinder, okay? But we are not done there. We are now going to talk about what? The breadth. Remember, this is still our rectangle. And then how do we calculate the area of a rectangle? We say area is equals to length times breadth. But look at our breadth, our length. Our length now have changed to be what? To be a circumference. The same length. Then our breadth now, do we still see a breadth here? Let me come back to this. Do we still see the breadth? Remember, I have said this, the same rectangle that I'm having here on hand, it is now changing. When I'm folding it, it is now changing to be our cylinder. We can no longer see the breadth. We can see the circle. We can see the height. It means that, look, you see our length is coming back. And then what is this? Our same height now becomes what? Our breadth. It means that now when we want to calculate the area of the surrounding of a cylinder, we are going to say a circumference, which is the length, pi d multiplied by height. Okay, but when you observe our cylinder, we have a circle and we have a circle, meaning that when we calculate the total surface area of a cylinder is equals to 2 pi r squared plus, we can open brackets, we can say pi d multiplied by height. Meaning that the first formula here is to calculate the area of two circles that are found in a cylinder. Now I'm going to go to my example. Here is a circle. How do we calculate the area of this circle? Is pi r squared, but we don't have one circle. We have two circles. That is why I have multiplied by 2. Okay, so I want to go, I would like us to take an example on that. Right, let's do an example. Let's say we are given a height of 7 centimeter and we are given a radius of 8 this one, let me say 17 centimeter, and in the radius it's 8 centimeters. Okay, now what are we going to calculate? We are now going to calculate the circumference of this cylinder. Okay, so our formula says total surface area is equals to 2 pi r squared plus pi d multiplied by height. So that means we're going to say 2 multiplied by 3,142, okay, into brackets. How much is our radius? Our radius is 8 centimeters. We're going to have 8 centimeters to the power 2 plus 3,142 into brackets. How much is our diameter? Diameter is equals to 2 radius, which is equals to 2 multiplied by 8 centimeters. That is equals to 16 centimeters. Okay, Then we're gonna have 16 centimeters here. Okay, then we close the brackets and then we multiply by, okay, everything can be multiplied here straight away. Let me do this. We can say 3,142 multiplied by diameter 16 centimeters squared multiplied by the height of 17 centimeters. So we're gonna have what is 3,142 multiplied by 2, right? 2 multiplied by 3,142 is equals to 6,284 multiplied by 8 to the power 2, that is 64. That is 64 centimeters squared plus 3,142 multiplied by 16 multiplied by 17. 3,142 multiplied by 16 multiplied by 17. That is equals to 854,624 centimeters squared. Then we're gonna have 6,284 multiplied by 64. That gives us 402,176 centimeters squared plus 854,624 centimeters squared plus 854,624, and that is equals to 1,256,8 centimeters squared, and that is our total surface area. Okay, so here guys, you need to make sure that you know exactly on how to substitute. Okay, right, we go into the next concept now. Let me see my papers. Okay, that was only one paper. Let me do this. Let me see. I want to see some. I want to check something. Okay, that was one paper. Okay, right. Let's move to the next concept. The next concept, we're going to talk about the volume. So, like, you know me, I start with the notes. Okay, so what is the volume? That is the first thing that we need to ask ourselves. What is a volume? Okay, volume is the 3D space occupied or available. Okay, is the three-dimensional space. I like to give this one available, or let me use this, the word occupied. Yeah, occupied by a gas, liquid. We can talk about water in the pool here, or a solid substance. Okay, so we can explain the volume as that. So when they also talk about the weight, they can also refer the volume as a capacity. Okay, so now we need to talk about the units. That one is very important. Units are used in volume. Okay, the units that are used in the volume, they are different. Okay, the units that are used in a liquid volume, we have two types of the volume. The liquid volume, remember, when we measure the liquid, we cannot measure the liquid with a length. You understand? meaning that you cannot measure your liquid with centimeters, meters, or millimeters. Okay, your liquid can be measured in liters, kiloliters, and milliliters, meaning that volume of liquids, volume of liquids can be measured in liters, milliliters, or kiloliters. Okay, but a volume of a solid can be measured in centimeter cubic, millimeter cubic, meter cubic, or kilometer cubic. Okay, we're going back to our shapes again. So I'm hoping not to spend a lot of time on volume, because volume is a straightforward in whatever shape that you are given. Let me show you calculations for volume. Okay, calculations for volume. Okay, calculations of a volume. Volume is equals to base area multiplied by height. Then you are done. This formula that I just gave you here, it talks about any object. As long as you can identify the shape on the base, then you calculate the area on the base, then you multiply that area by the height, then you'll get the volume of that shape. Okay, of that 3D shape. Okay, remember now in the volume, now we are still talking about a 3D shape. We cannot pour water here. We need what? A 3D shape like this, so that we can pour water inside. Okay, we need a bath tap so that we can pour water in there. We need a cup so that we can pour water. Okay, but we cannot pour water on top of a table. Okay, right. What are we going to do now? Let's start with the rectangular prism again. Shape. Okay. I have mastered it. Right, we are going to talk about our rectangular prism, which have the length, the height, and the breadth. Okay, so what are we going to check? We are going to check the base. Let's check the base. So when we observe our base here, the shape on our base is a rectangle. Now, the question comes, how do you calculate the area of your base? What is your base here? Your base is a rectangle. How do you calculate the area of a rectangle? Is length times breadth. Can we see the length and the breadth on the base? And that is correct. We can see them. Okay, then we multiply that by height, and we have our volume. Let's go and take the units there that we used. We say the length was 429. 429. Length 4, breadth 2, height 9. These are in centimeters. So if we want to calculate the volume of this, now we're going to say the length is 4 centimeters multiplied by the breadth is 2 centimeters, the height is 9 centimeters, which is 4 multiplied by 2 multiplied by 9. 4 multiplied by 2 multiplied by 9. That gives us 72. Now, what happens to this? We go back to the basics of mathematics. Centimeter multiplied by centimeters. Our base are the same. So what do? We add our exponent. So it's going to be 1 plus 1 plus 1. So we write one base and then we add 1 plus 1 plus 1, which is going to be centimeter cubic. So our answer here is going to be centimeter cubic. Jackpot. Simple as that. Okay, so now let's go and check. That means that is the volume of a solid. Yeah, of a solid. Therefore, now you are going to be given the relationship between volume. Listen to me. You're going to be given the relationship between volume of solid and the volume of the liquid. Don't make a mistake. You can never have the relationship between a distance and a volume. Okay, you can only have the volume of a liquid and the volume of a liquid, a volume of a solid and the volume of a liquid, in that order. Okay, now let's go check out our next shape here. So on information number come again, on the next item here, the next item we're gonna have the next shape, we're gonna have a cylinder again. Let me see if I'm going to win. Okay, I'm winning. So let me, okay, before I do that, I just have to explain how to calculate the volume there. So we go back, we check the formula. The formula of calculating the volume. Okay, this is our cylinder. How do we calculate a volume? A volume is equals to base area multiplied by height. Okay, so now we go and check what is the shape on the base. The shape that we see on the base is a circle. Now how do you calculate the area of a circle? Area of a circle is pi r squared. Then we multiply now by height. I gave you the example here. I just want those units. It was 17.8. 17.8. 17 was what? 17 was the height, 8 was the radius. Radius is 8 centimeter and then the height is 17 centimeters. Okay, therefore now how are we going to substitute? We're going to have 3,142 into brackets. Our radius is 8 centimeter, then to the power 2 multiply by our height of 17 centimeters. That is equals to 3,142 multiply by 8 multiply by 8, that is 64 centimeters squared, multiply by 17 centimeters. That is going to be, okay, 3,142 multiply by 64 multiply by 17, that is 3,418 0.496 centimeter cubic. So if we round it off to the nearest two decimal, is going to be 50 centimeter cubic, and that is it. Now people will ask, why do we have centimeter cubic? How did we get it? Because we have a centimeter here, we have a centimeter. That is because we have a centimeter squared multiplied by centimeter. If the base are the same, we add the exponent. Why am I writing 1 here? Is because any number is to the power 1. So it's 2 plus 1, which is equals to centimeter cubic. Okay, so remember guys, in math they can not always tell you to calculate the volume. Sometimes it will be that calculate the height, but if they say calculate the height, you must count how many values are here. So if you check, the one value is volume, one value is the radius, one value is the height. So you have 3 values. So if you have 3 values in a formula, it means that it is a must that your examiner give you 2 values so that you can calculate the remaining value. So in this case, our unknown value was the volume. So our given values is height and radius. So you can use the same formula and look for the missing values. Okay, so those are the more detailed curriculum that I'm teaching in my private mentorship. Okay, so this is where I'm going to cut my session. If you have not subscribed, make sure, I'm still emphasizing, make sure that you subscribe to my channel. And if you like what I'm doing and then you want to pass Maths Lit with distinction, make sure that you pull up through to my my private mentorship, so that I can be your mentor, I can be your tutor. Okay, so that we can talk together and then work together so that you can get better results by the end of the year. That one, I guarantee you, I have an experience with that. I've been doing it and I'm still going to do it. So thank you guys, thank you for watching my video. See you next time.